video is on inverse functions, and we're looking at rational functions and trying to find the inverses of those. So we have let m of t equals 2t minus 2, all divided by t minus 3. That's our function. First, we want to figure out what the domain is and state that for m, and then also we're going to find m inverse and state its domain. So let's go ahead and do the grunt work on that. I know you can probably figure out the domain, so try to do that on your own. Just pause for a sec and jot that down. So basically it's t not equal to 3, but I just wrote it a little fancier in the set notation, but it's fine just to jot down not equal to 3. So I have m inverse. We have to figure that out. So again, we're going to switcheroo. So first I'm going to write the y equals 2t minus t over t minus 3. And then I'm going to swap everywhere I see a t, I'm going to put the y. And everywhere I see the y, I'm going to put a t. So t equals 2y minus 2 over y minus 3. Then I'm going to solve for y and then replace the y with m inverse of t. So to do this, we want to clear the fractions here. So we're going to multiply both sides by y minus 3. So I end up with t times y minus 3 equals 2y minus 2. Then I want to distribute here. I actually just pull this up over here to have more room. So I have ty minus 3 equals 2y minus 2. Remember this from the skills at the beginning. We did a lot of this. So now I need to collect my y stuff to one side, and my my other stuff over there. Well, I'm going to end up with a t and a y here. But ty minus 2y, so I'm collecting over there. Then I'm going to add this 3 and minus, it should be 3t. And then 3t minus 2. Then I need to factor out the y, because remember I need to get it by itself. So I have y times t minus 2 equals 3t minus 2. And then I'm going to divide both sides by t minus 2. Get the y by itself. And when I do that, I'm actually going to just erase that y and write m inverse of x. Remember, be careful how you write that. And that is my goal. I got the first part of that, stating its domain. We would write, and make sure you label that as domain. So domain for that would be t not equal to 2. Well, t is an element of real numbers such that t is not equal to 2. So if you think about it, if I am switching up, so whatever my original thing here, I have t and m of t. That's my original, like say that were a point. So my range originally was m of t. But in the inverse, I'm actually making it be like m of t, and then t is my output. This was the inverse. So since they switch, what my domain is for my inverse is the range of my original. So it takes a little bit of getting used to. So we could write it, m of t is an element of real numbers such that t is, or m of t, or you could just say y is fine too, is not equal to 2. So just note that. So what my range for the inverse would be is my domain. See, it switches. So all the x's become the y's in the inverse. So the range is m inverse of x element of real numbers such that m inverse of x is not equal to 3. So that's something that I know people get hung up on, but if you just think that the range is the domain, okay, the inverse range, they switch, right? So it's just a helpful thing to just really start to get down. So for part C, we're going to find m of m inverse of t and state its domain. That's similar to what we did before to see if we should come out with t, right? We know that. And then there's another one down here to try. So you can try both of those as classwork if you want, but definitely one of them you should do as classwork. They both involve some tricky stuff. So I will say that one's classwork and I'll do this one here, the C right now. So, and then you'll pause and finish it up. Find m of m inverse of t and state its domain. So I'm going to look back up. I'm going to shrink this up a little. So we have the m inverse. I'm going to plug into the m function. So I will end up getting m of the 3t minus 2 over t minus 2. And that's going to plug into my, I'm just rewriting it here, t minus 3, my m function. So everywhere I see t, I have to plug that in. So don't forget to do that. It gets a little tight in there. You know, people forget to do one or the other. It's real easy to do. So I have 2 times 3t minus 2 over t minus 2 minus 2. So I'm going to double check. Did I get everything in there? This whole thing in for t here. Now I have to also do that whole thing in for t in the numerator. Denominator. I got it in the numerator. Now I'm doing denominator. So I have that and then minus 3. Let's make this a little smaller. So now what I want to do is simplify this. So I did figure it out, but it's a big mess. It's a complex rational. So I need to simplify that. And how we do that is multiplying by a form of 1, the LCD over the LCD. So when we do that, we're going to look at t minus 2 in our denominator. The other denominators are 1. So if I multiply this whole fraction, it's going to kind of put it out here, by t minus 2 over t minus 2, I'm really multiplying by 1, right? And then I would have to distribute that to both of the terms in the numerator and the denominator. So it does get a little bit tricky. So what I do is I just kind of write it on both sides there. So I'm going to write the t minus 2 just to save space here. Make sure you use parentheses and then t minus 2 here. So what happens is I will end up getting some things to reduce out. So I get the t minus 2 here will go to 1. T minus 2 here goes to 1. And now this is my distributing. I don't have anything to cancel that out with. So what I end up with is 2 times this 3t minus 2. So that'll be 6t minus 4. Then I end up with the minus 2 times the t minus 2. So I have to, again, make sure you distribute, including that negative. That's pretty popular to forget. I definitely do that sometimes. And then all divided by what's in the denominator, 3t minus 2, because that all reduced to 1. But over here I have minus 3t, and don't forget to distribute the negatives there, so that's going to be a plus 6. All right, so now we have some things we can just get rid of, literally cancel out, right? So we have a minus 4 plus 4. We have this 6t, and the minus 2t will become a 4t in the top there. Then we also have 3t minus 3t. That goes out, and we're left with minus t plus 4 plus 6. And I get a 4. Kind of jumped the gun on what I was saying. And now those reduce. Remember, that's what we want to happen. So don't worry about that. Like, that's a good thing. And then I'm left with t ultimately. So that means I actually did my calculations correct in figuring out my inverse. Now, sometimes you might be a little off on the inverse, and so then it messes you up in the check, and you know you should get t, but you're not getting t. So just write me a note on a quiz or a test, you know, that's what's happening. Can look at it and see what happened. I do give some partial credit for like taking what you found, even if it's the wrong thing, and trying to work with it. So we're not quite done though. Actually, I shouldn't put the box around there. We do need to state the domain for this value t, and remember we needed to figure out what the inside is, right? So if our inner function is m inverse of t, then we need to look at the domain for that. So we're going to definitely write a comma. We don't have to do all the fancy set notation. We can just write comma and then put t is not equal to 2, because that won't work. We can't start with an undefined situation. So now I'm done. I'm good with that one. So pause the video, try D, and see how that goes. I'll write up the answer. It's pretty similar, actually, because they're both, you know, it's rational. So that's how they work. So follow the same process as I did, except your denominator is not going to be t minus 2. It'll be all flipped around. Okay, so here's the answer for part D. My inside function is the main function m of t. I plug that in for t everywhere I see t. And so it's the same process we used before, except our LCD is going to be t minus 3 over t minus 3. I distribute that to both sides. Don't forget to distribute when you're multiplying out over here. So just check that your numbers all match up. Let me know if you have any questions. I did set the comments in Canvas to go to me, so when like you submit your homework, I should get those right away. If you don't hear back from me within a day, then just email me directly, because that means somehow the notification didn't come to me. And I won't necessarily go grade those till a while later. So here's my result. It comes out actually pretty much the same. What you want to be careful not to do is like, don't cancel out these 6s. Remember, you can't cancel terms with terms, only factors with factors when you're like dividing on a fraction bar. What you can do is like this term that are additive inverses that are opposite of one another, those actually calculate out to 0. So those literally cancel. So that's when we can cancel terms, when we're just looking at if they're, you know, opposite one another, but not when we're doing, you know, reducing fractions. So we have t, but be careful here because your inner function, the t can't equal 0. It's okay if it's 2 this time, but it can't equal 0. So make sure you write it that way. So that's it for this video. Thank you for watching. I'll do some more examples in more videos, and I'll put them all together in a playlist for you. Have a great day.